So you've got a cell phone that is being dropped from the top of a 73-meter, that's my numbers, your number will be different, but 73-meter high stadium. And as the cell phone is dropping, the time is clicking, and 2.3 seconds later, a coin is dropped from the same height. So now both the coin and the cell are dropping at the same time. And then when the cell hits the ground, okay, what they want you to figure out is how high above the ground is the coin at that moment. So if you could just imagine, let's say the cell hits the ground and you could just stop time, freeze time for a second, and you look, the coin would be suspended somewhere in midair, let's say about right here. What is this height is what you're trying to figure out. Okay, that's how this problem works. All right, so I'm going to do two things. First thing I'm going to do is I'm going to just tell you in words how you would do this without actually putting the numbers down. And then maybe at that point, some of you may just stop the video and just go ahead and tackle it yourself. You might have enough information to go ahead and solve it. Then after that, I'm going to actually go ahead and solve it. I'm going to actually put the numbers on the table, actually run the math, and hopefully I'll get this number up here. This is the actual answer to this particular combination of numbers. Okay? All right, so that's how we're going to do it, and let me go ahead and just explain how you do this first. What you want to do is you want to first figure out what is the delta y of the cell phone from the top up here. I'm sorry, not the delta y, you already have that. First thing you're going to do is you're going to figure out the delta t is what I'm going to say. What is the delta t of this cell phone? In other words, how long does it take for the cell phone to hit the ground? Okay, you already have your delta y. You're going to make that negative, and you're going to run your kinematics equations to figure out how long it would take for an object dropped from that height to get to the ground. That's a real important number. We're going to call that delta t of cell. Okay, you're going to subtract from that number whatever time it takes, or whatever time is given basically right here. That's the amount of delay time. So you can kind of look at that as the delay time. In other words, the cell phone was falling for that many seconds before the coin was dropped. Okay, so when you think about it, if you subtract that number from the time it takes for the cell phone to drop all the way to the ground, if you subtract this number, then now when they're both, the amount of time that's left for the cell phone to fall to the ground would then be the number you have for the coin, if that makes sense. So by subtracting this number from the time it takes for the cell phone to hit the ground, you would have the delta t of the coin that you're going to need for the coin table over here. That's how much time the coin has been dropping before the cell phone hit the ground. Okay, I hope that makes sense. But that's what you're going to do. Now, once you do that, once you have this delta t of the coin, then you're going to figure out the delta y of that coin. In other words, how much distance or how much displacement, a better way to say it, how much displacement do you have during the time that coin has been falling? Once you do that, then you're going to have two delta y's. You're going to have the delta y of the cell, which you already had that one. That was given in the problem. And then you're going to have the delta y of the coin right here, the delta y of the coin. You're then going to subtract those two numbers. You're going to take a delta y cell. Now, by the way, these are going to be negative numbers. Just take the absolute values. Ignore the negative at this point. So take the absolute value. Absolute value means, drop the negative. Don't worry about the negative. Just take these two numbers and subtract them. Okay, so you can take delta y cell with no negative in front of it minus delta y of the coin with no negative in front of it except for the minus that you already put there, so that you're subtracting the numbers, and that's going to give you your final answer. You're going to want your final answer to be positive because you are not looking for a vector, you are looking for a scalar. They said the height, that is a scalar. That's how you do it. I'm gonna pause the video actually, and I'm gonna grab something to drink. And when I come back on here, I'm gonna actually go through the math and show you. Or some of you may say, okay, I'm ready to go do this myself. I do encourage you to try it yourself, just based on my explanation first, and then you can always come back and watch me do it. Okay? All right, I'll be back. All right, students. I'm thinking that if you're listening to me, you probably want to see the solution, and that's fine. All right, so let's go ahead and work that out. All right, so we're going to first address what I said first. We're going to figure out the time, the delta t of the cell phone. So I'm trying to figure out delta t of the cell. I'm going to put c there for, well, let's do this. Let's make sure we don't get confused. Let's put delta t of the cell phone for p, okay? And that's what we're after. So initial velocity is equal to 0. G is equal to negative 9.81 meters per second squared, okay? That's one, two piece of information. Delta y, the cell, that's given at negative 73 meters. That's going to be your delta y of the cell phone. Three pieces of information is all I need to calculate anything. And looking at this, okay, so let me show you how this works. All right. All right, so we're going to need this equation. We're going to need delta y equals vi delta t plus 1/2 g delta t squared. But vi is 0, so since vi is 0, we could literally knock out that entire middle term. And that gives you delta y equals 1/2 g delta t squared. And we need to get t by itself, okay? So, you know, again, I don't want to go through all these steps because I'm trying to make this as quickly as possible. So you're going to multiply both sides by 2. You're then going to divide both sides by g, and then you're going to take the square root of both sides. You will end up with delta t is equal to 2 delta y. That's going to be delta t. I'm doing this from home, and I'm got to get used to where my tablet is. It's always a little bit different. 2 delta y over g. Okay, there we go. And this entire thing is in parentheses and is in the square root symbol. Okay. And let's go ahead and do the math here. So that's all right. So that's going to be the square root of 2 negative 73 divided by negative 9.81. Of course, we're taking the square root of that. That's going to be 2 times negative 73 equals, we're going to divide that by g, that's negative 9.81. Okay, we're going to take the square root of that. 3.858, I'm going to go 3 digits, 3.8, because these are all intermediate steps. Actually, I'm going to go 4 digits. 8578, 3.8578, okay. 3.8578, which really I didn't need that because now that I'm thinking about it, all I'm doing is subtracting 2 digits from it, so, but that's okay. All right, so we're going to subtract from that. I'll just hit minus 2.3, and that's going to give us 1.558. That's what I'll go with 4 digits on. Okay, so 1.558, 1.558 seconds. Okay, that is my delta t of the coin. I want to go ahead and realize that the coin also starts at 0. The coin is also in the hands of Earth, so it gets 9.81 meters per second squared. And now I want to go ahead and figure out the delta y of the coin. I'm just going to put c for coin. Okay. All right. Let's go ahead and see what equation do we need there. Looks like we need the same equation, but we don't have to isolate the t this time. So that's going to be, and let's see, I'm over there. Oh, that's right. I'm not on the video this time, so I don't have to worry about my face. And okay, it's doing that funny little lockup thing again, so I'm going to have to pause and fix it and come back. Okay, I will be right back. Problem solved. Okay, so let's see, we're trying to figure out delta y, so that's delta y of the c is equal to, so look, it's this equation right here, delta y equals vit plus 1/2 gt squared, but again, I don't need that middle term because vi is 0, so I'm not going to waste time writing it. That's 1/2 g delta t squared. That's going to be delta y of the coin equals 1/2 negative 9.81 times t squared, that's the 1.558 squared. 1.558 squared. I'm going, right, we're going to go ahead and get that. So 1.558 x squared times, I'm kind of going backwards here, negative 9.81, negative 9.81 times 0.5, negative 11.906. Negative 11.906. Final answer is going to be this number right here, the 73, minus that number, but I want to ignore the negative signs. So now we're ready for our final answer. This is going to be the height is going to be equal to 73. That is the height, the delta y of the coin without the negative symbol in front of it, and minus 11.906. Okay. $73 minus 11.906 equals at 61.094. 61.094. All right, well, that's okay. That's definitely within range, so we're fine there. You know, you're going to get slightly different numbers when you start going that much over, so that's okay. Okay, that would definitely work. All right, so we're good to go there. I'm going to go ahead and end it here. Again, make sure you message me if it's not too late on Canvas night. Make sure you message me if you have any questions. And I'm going to go ahead and end it here. Have a great day. Thank you.